You want me to read it?
Mm-hmm.
Oh, a group of students construct a ballistic pendulum to measure the muzzle velocity of a rifle. One student hangs a block of wood from a thin wire that is suspended from a tall ceiling. Another student fires the rifle so the bullet travels horizontally into the block of wood. Before the collision, the bullet travels to the right, and the block of wood is initially at rest, as shown in the diagram. After the collision, the bullet is embedded in the wood, and the bullet block system swings upward without rotating. Yeah.
Which means there's no rotational motion involved, right?
Mm-hmm.
So basically, the object itself, you say something about it's being over here.
Mm-hmm.
Is that at the maximum height?
Yeah.
Yes?
Uh-huh.
At max height. And it is only translational because the object is not rotating. Okay. Right here, right?
Mm-hmm.
The object is self-embedded in the mast. So basically, I'm telling you that this one is very difficult because you have to think backwards. So, you know, this one right here is the length, right here, right?
Mm-hmm.
You're gonna have to figure out the height, which is right here. So, first, you're gonna have to figure out what this is. Right here. I show you on the piece of paper that kind of teacher guideline. Remember, students supposed to be utilizing teacher's guideline up to the maximum potential. You know, not trying to cover up information. That's what you've been doing.
So you want to find the height?
Yeah, I want to find the height. What did I do?
Oh, you do the length
Uh-huh.
minus the length times cosine.
Because this part is right here, length times cosine,
Yeah.
and that one is the sine. You want to figure out the differences right here, right? Which means it's the whole thing, subtract that. That will give you the height. Okay, from here to here, I'm just going to say point 1 and point 2. So tell me what's going on at point 1, from point 1 to all the way to point 2, in terms of energy.
At point 1, it's at rest, and then the potential energy is it low?
It's not at rest. This thing is swinging.
Oh yeah, it's swinging
Then
up.
the bullet is right here. You know, when you about to
Yeah.
get hit. For example, if this is you,
Oh.
if this is okay, just make it to the real life. To make it a person right here, not hanging. They're trying to swing the pendulum. I don't know what they're trying to do. Right here, right? Okay, for example, these people is running because they were being chased after. They're holding onto this rope which is attached to the ceiling right here, right?
Mm-hmm.
Their purpose was trying to use this rope and try to jump over here. But then, you know, at the same time they were running, the bullet is chasing after them. He's competing with the bullet.
Mm-hmm.
So, do tell me what's going on right here.
He gets hit and then he swings up.
You get hit. Okay, depending on where they get hit. It doesn't matter where they get hit, right? As long as the bullet itself will be embedded. Because at the end, he's gonna die anyways. Yeah, here. The bullet is, no, not his head. Okay, how about this? Shoulder. And the bullet itself coming with a certain velocity, not to mention who's shooting the rifle at him, right?
Mm-hmm.
So at the same time, that's what happened. So what's the total mass right here?
60 kilograms.
That's the say so?
Oh, it doesn't give me mass.
So we're just gonna say the mass. Okay, this one mass of bullet, right?
Mm-hmm.
Mass of person plus what? Mass of bullet. And this one is the same, right?
Mm-hmm.
Mass of person plus what? Mass of bullet. The only thing that is different is transformation of the thing.
The height.
The height. And remember from the earlier lessons, right, that when you're talking about the energy conservation of energy concept, the mass does not really matters because they have the same heat with the same weight. So at this point, what types of energy?
There's potential.
There's no potential.
Oh,
Remember,
yeah,
it's the
kinetic.
point of reference. So it will be this, right? What is it? Bullet
V squared.
V
Oh, yeah.
squared. And this one would be what? mgh. And h is L minus L cosine, right? You know what L is?
The length of the rope. I mean the string.
So now we want to set them equal to each other because the energy is conserved, right? So that would be mg L minus what? L cosine equal to 1/2 m. I need you guys to be more engaged than this. I'm so boring.
Okay. 1/2 of
Then, right? So inner. So what's the point we're trying to do over here?
trying to find the length,
Nope.
the velocity.
Trying to find the final velocity, right? Upon the impact, which is this one. So that would be velocity is equal to what? Square root 2. Correct?
So 2g. Yeah. Yeah.
Okay, so basically this is the velocity after. So now we want to figure out, how in the whole wide world he has anything to do with his bullet by using the momentum. So we break it down. So this is a new task, right? He's being chased after by the bullet. So this is before right here, right? Is he running?
Yeah.
No,
But he's not.
stationary. Right? Why is he not running?
Because he's attached to the rope.
He's hand to the rope. I mean, he's attached to the rope. There's no way he can get out. So that means his velocity is equal to
0.
okay. The bullet itself has the mass, right?
Yeah.
And it also has the velocity. So after collision, what happened?
They both move.
Move together.
Yeah.
So after it become what?
They become one system.
Become elastic. Is it elastic or inelastic?
Elastic. I mean inelastic.
Okay, at this point, I want you to guide me through the process because, okay, you're gonna be the one who actually telling me.
So it's M1 V1 plus M2 V2 equals M1 plus V1. I mean M1 plus M2 and then V2. Yeah.
Okay. The whole formula itself indicating that the energy is conserved. Sorry, not energy. Momentum is conserved. So it's conserved. Okay. So tell me, what do you know from the earlier part?
The M2 V2 cancel out
Why?
because the person's stationary. And then that's pretty much it.
Right? Okay, remember the final velocity, which is, by the way, it is the initial from this part. So what was your final velocity? Or what was your initial velocity there?
0? Oh, that one. 2g. Isn't that after? Like once it's like moving?
No, it is after in this case, but it was before in that case. So we're thinking backward, that's why it is very difficult. I don't know if you guys will do it, but go ahead, I have faith in you all.